Woodsman the peasant. What are you doing all the way up there?
ChatGPT said I need to use behavior trees, James. My NPCs aren't good enough.
I don't think behavior tree is a real tree, Woodsman. Why don't you come down from there?
But I probably have to go all the way to the top to know for sure.
No, Woodsman. Just come down from there. You don't have to go all the way to the dangerous top. That boy's gonna die.
There's a squirrel up here! So welcome back, you guys. Thanks so much for joining me again. This last couple months were a real humdinger. I started out trying to make my soldiers exist in the game, but I had trouble as I was swapping out their togas for leather armor. I ran into an issue where my level of detail homebrewed script proximity manager sort of started to buckle and fail. And it was because I was trying to pass too much data in between these two entities, near and far. Initially, I had my own homebrew level of detail system that would call the skin mesh renderer and swap it out with a kind of mesh renderer substitute. And over the past couple months ago, I can't remember exactly, I really wanted to use the default built-in level of detail component that Unity has, and I found that after doing that, I actually just did not get the frame rate gain that I had hoped. I discovered that the level of detail component just disables the renderer, that you cannot have a bunch of visible skinned meshes on the screen. It's this number right here that my mouse is wiggling over. So over here in the Unity stats window, this is the number you really want to get down if you want your game to perform well. This little one right here. So how do you do that if you want to have 30 NPCs? And the way you do that if you want to have 30 NPCs is by not having the skin mesh renderers not even enabled or disabled rather, but actually just straight up deactivated. And I had discovered the gain the first time I did it. Okay, so we did that. The next thing we did was we figured out I redesigned how I was generating the cities, so I wasn't searching for flat areas to build houses. I was instead just sort of flattening the area around a house instead at runtime. So that's a better way of doing that, so that looks cool. And I'm using like a Gaussian or a normal curve to drop off the magnitude to which it levels as you move away from the center point of the house, so it sort of blends in with the rest of the hill slope and things like that. And so there's that, and that was really great. And then the next thing we worked on is hitboxes and hurtboxes. So before I was doing raycasting, I would raycast the player, and it would tell me what the state of the animator was in, and that's how I was detecting how to know when to block, was by changes in the animator of the player. But when the NPCs are fighting each other, and many NPCs are fighting many NPCs, that doesn't scale well, and that sort of breaks down. So instead, we're using hitboxes and hurtboxes now. And a hurtbox is sort of like a capsule collider or a box collider that we've wrapped around the NPC, and the hitbox, or sphere collider maybe, and the hitbox is sort of these two little boxes I put on the NPC's fists, and they're usually deactivated. But I'm using like an event-driven programming kind of thing to kick off a event in the punching animation, and that program that I kick off, the function that I kick off, enables these box colliders so that you can tell sort of when someone is punching you by a collision with your hurt collider, which exists outside of the NPC. So I don't want to get too technical. I may have already done that. But the idea is that now we have a much scalable, much more performance-friendly way to detect if someone's trying to punch you so that you can react with a block. That's the whole point of that. That took me a little while. The other thing I've been working on is bringing back some of the functionality, the deployment functionality, for example, and some of the other like social functionalities and things like that. So now you can do the left mouse button drag and deploy again. And I added the ability to do this with multiple groups of NPCs. So now you can have group 1, group 2, And ideally, in the end, I want to have, multiple, sort of like a modular sort of list where the player can have as many groups as they want. But right now, I kind of want to redesign the UI a little bit, so I'm not trying to go too deep into that right now. So that brings me to behavior trees, which is really the big thing that we did these past couple months. And so yeah. All right, so I was sitting with so just as I had been sort of redesigning a lot of other things, I started questioning how I was doing the NPC AI logic. And this is really what this video is all about, is the revelation that if I want to have, really if I want to be able to do complex things with NPCs in the future as a game dev, I need to embrace this concept of the behavior tree, which is like a data structure or like a design paradigm, or like it's like just a way you build a script to do a thing, to do the AI. I'm trying to describe it a little bit better. It's like instead of using a finite state machine where flags just trigger animation changes, you can model the brain of an NPC in a more complex way that allows for sort of like modularity in a sense, where you can copy and paste, sort of like kind of like a Nintendo 64 cartridge. Like you take one, you pop the other one in. So like behavior sort of is similar. So go from here to there, do that, this and that. So you can have the same beginnings of a behavior and then swap out the middle and things like that. And that's what behavior trees allow for. And it's more. It's like you can, at runtime, even procedurally change what a behavior tree is, which is fascinating if you think about that. So that means you could change what the behavior of an NPC is based on what it experiences. Though you might want to just put everything already in a gigantic behavior tree and just pick and choose. But the idea is that the behavior tree is just selectors and sequences, which are two different ways of sifting through children. So a selector will choose which one of the children it wants, and a sequence will do the actions from child 1 to child 10 or whatever. And so you can build NPC behavior with these two fundamental ideas. Somebody used the example eating a banana. Eating a banana involves peeling a banana and then eating it. So it's a sequence of events. And a selector. So a selector is like sort of choosing which one of the group is the correct one. So that's more like a finite state machine testing flags. A lot of it's actually just testing flags like a finite state machine. But the point is that you use these nodes, and they each have a tick method. They all have a tick method. In fact, they must have a tick method because they inherit from a class that has a tick method. And the tick method runs every single frame, but you don't have to. You could have it run every umpteenth frame, every 10th frame. If you want here, the tick frame is just literally in this update method, and you could just have an incrementer and have it reset and just do it every 15th frame or whatever. But the tick is sort of like a pulse, and the tree and the NPC's behavior pulses, and every frame it pulses through this behavior tree and determines which node it should be in through testing different flags and figuring out where in the sequence it is and this type of thing. And it's smart enough to do that, and that allows for a much more alive NPC, and not just an NPC that you can scale the behavior of more easily, but also an NPC that has layered behavior. Because at the top level, you could have a selector, which selects which kind of higher level state the NPC exists in right now. So, for example, the NPC might be going about its daily business. The NPC might be, these are the different states. The NPC might just be standing there, and that might be the sort of catch-all. I screwed up my behavior tree, so I just want him to be standing there idling and not in T-pose. That might be the last thing that you select, But the other ones might be, I want to go about my daily business, and so the NPC goes and starts fishing. And then another one might be, I want to respond to the player's commands. And they're actually sort of in they're sort of in an ordering themselves of importance, because at the top you might have react to being punched or something like that. And so an NPC, the good games, they have NPCs that sort of are reactive to the environment. So that's my point I'm trying to make, is that if you want your NPCs to be reactive and alive, and like I picked up like a pine egg or whatever in Skyrim, and the guy sitting there was like, said something like, I forget, it was like, don't drop that now, or something. It was so funny. That's, I think, what really brings these games to life. The sense of immersion. It's really about the NPCs reacting. They're reactive to what you do. So Bethesda is a great example of NPCs, successful NPCs, really. They did a great job. It really makes you feel like the game's alive. And they have daily schedules, and they go about their daily business. Red Dead Redemption 2 is another good example. And I was trying to tease out of ChatGPT, like, did they use behavior trees? And ChatGPT was like, very likely yes, but we don't know. It's probably some proprietary thing, blah, blah, blah. But Red Dead Redemption 2 NPCs are hilarious. And they're reactive, and they do stuff, and they'll make decisions based on things that happen, and that's, I think, what's so important, and that's what I'm trying to bring home. That's the point of this video, is that sort of like NPC complexity is sort of when an X approaches infinity type of thing. You're never really gonna get it where you really want it, because that's sort of impossible and takes infinite stuff, but it's like, sort of once you cross this threshold, you want to switch from state machines to behavior trees. So you need to think about, like, what are you going for with your game? What's the scope? What are you trying to do? Because for me, I reached this point where I was like, yeah, this is great, but like, I just want more from my NPCs. So you might reach that point, and you might want to take the leap. I'm glad that I did. I'm glad that I know and understand behavior trees. I didn't use some third-party software for it. It's just straight code. It's not a big class. I'm trying to show it to you guys. Like, here's what it looks like. Here's the tree. You know, it's not very big. My NPCs aren't very complex right now. They just basically react to being punched. So as it gets bigger, it's going to get more complex. But really, it's not that crazy, this concept of the behavior tree. I took a leap, and I'm glad I did, and you probably want to do that too, because you might want your NPCs to have different layers. And it's not that it's impossible to do it with a state machine, it's just things kind of just get too complex and complicated with the state machine. And so it's like when you know your NPCs are going to be a certain amount of complexity, you want to just kind of take the leap of faith and realize you need to be using the big boy pants NPC model. And that's behavior trees, not state machines. Although state machine is still there, I'm not saying that the state machine is gone. The state machine is essentially the animator, more or less, window in Unity editor. So this is the state. This is what a state machine looks like. It's like a web, and the idea is that now you want to make things more complex than this. Instead of just changing animations based on some flag, you want to have more complex code behind it, and you want the NPC to have different layers, and that's done with a behavior tree, right? That's just basically what I'm trying to say. So that's the behavior tree stuff, you guys, and yeah, freaking A, that one was friggin' hard. Alright, so last time I promised a 10v10 NPC fight, so here it is. So what does the future have in store for the game? Well, it's coming along. I have a couple great names. I don't really want to pick a name yet, because like I just sort of know that somebody else is going to come out with the same game name. I'm so far away from market that I just don't even want to think about that stuff. I don't have a fun game yet. So The future, so I just have to develop more. The next thing I'm doing is going to be hard. It's going to be me finally figuring out how to like essentially load and save tiles, and including not just the terrain and stuff like that, and the trees and rocks, but also the cities, and being able to procedurally generate a city at runtime. As the player runs through the world, I want new tiles to pop up, and then, perhaps there's a city on that tile, and then a city will pop into that tile as well. And ultimately, I'd like there to be like roads in between the cities, and then how would you do that if the city hasn't been generated yet, and there's all these other problems. So probably what I'll land on is building two tiles rather, with two cities on them at first. And that'll be how the game begins. Tale of Two Cities is the next step. And the fun part of that will be like, as soon as I have two cities that are able to load and save, which won't be the fun part at all, that'll be horrible. There'll be like maybe a trade cog that goes back and forth. That'll make it fun, and it'll add something new to the game. But yeah, I'm hopeful. And then after that, I'm going to be doing something similar with trading by sea. So I need to solve the problem of like, where are cities that actually exist already? Are they already doing trade? How big is the initial map? Stuff like that. And then after that, we're gonna get into even more interesting things like administration stuff, like being able to be the city leader, what that means, collegiums, like having like trade schools and like just different like collegiums. That'll be fundamentally that should turn into like religion eventually. Maybe like tailoring and tapestry, and then we're gonna start getting into banditry and like really enemies coming and fighting. So that's on the agenda, you guys. That's on the agenda. So there it is, you guys. Another devlog. Don't give up on your dreams, you guys. You just can't do it. Even an inch, in the direction that you want to go, feels like a mile. Leo. Don't forget about Leo. A bear mauled Leo, and then he even ate like a raw kidney or something in the Revenant. So if Leo ate a raw kidney, you can do it. And there's other things. There's other inspirational things. What about Frodo? Frodo Baggins. You know how far he had to carry that ring? Turned his skin black and all that weird stuff. Samwise Gamgee had to carry him the last bit. Don't forget about that. So that's why you never give up, you guys. Never give up on your dreams. This has been Woodsman the Peasant. Make sure you hit those buttons and walk softly, and always carry a big dream, you guys. Peace.